Hello, this is Dr. Song Xu of Keysight Technologies. In this video, we're going to show you how to do the basic setup of imaging AC mode and contact mode in liquid. We have a sample, which is this piece of gold-coated mica. We have a sample stage. We have second sample stage for alignment. This is the liquid cell we're going to use today, and of course we need to use tweezers and a flat screwdriver. First, let me show you how to assemble the sample on the sample stage. You take the sample out, have the imaging site facing up, the liquid cell on top of it, and then use the screwdriver to rotate, push down and rotate the dovetail in order to lock down the liquid cell. Now the sample is ready. Now, before we mount the sample onto the AFM, let's take a look at the sample. With the liquid cell on, you can see the side view of the sample is blocked by the liquid cell, and therefore you cannot judge the distance between tip and sample, and it's very difficult to do rough approach. That's the reason we need to have another sample stage with a similar sample thickness on it to do a pre-alignment. Now from side view, with this help of this lens, you can see the distance between tip and sample. So you can use this manual switch to move the sample close to the tip. You can also do this rough approach with the help of the optical microscope. Here's how to do that. First of all, turn off your laser, and then zoom in your optical microscope. Now take a look at the computer screen of your optical view. When it's zoomed in, you will find that there's two images of the cantilever. Move your focus up and down, you will notice that 1 and 2, the two images has a different height. The first image of the cantilever on top is the image of the cantilever itself. The second one is the mirror image of the cantilever that's reflected from the sample. Here's how to do that. You focus on the tip and focus down a little bit until you see two images of the tip. And then we use the manual approach to move the sample up until the two images overlap with each other. And we know that the sample is very close to the tip. Now as we can see, the two images are very close to each other, and therefore we can say the sample is very close to the tip. Remove this alignment sample. Then we will add liquid to the actual sample itself. Add enough liquid so the liquid covers the sample surface itself. And turn on the laser. Now one thing notice is that when we have the liquid in, the reflective light spot of the laser will shift to a lower position. That's because of the different optical index of the liquid compared to the air. In order to have the detector to capture the laser spot, we need to realign the detector. Let's take a look at the software. Now we're ready to go to the software and do the tuning of the AC mode and the approach. And we can open the tuning window. Now, in AC mode imaging in liquid, you cannot do automatic tuning. Tuning has to be manual. So we switch to manual tuning, have the start frequency at 10 kHz and end frequency at 150 kHz, drive around 5, and gain X2. And we click the manual tuning. Notice there are many peaks appear to be of its resonant frequency. That reason is that the liquid will make the vibration of the cantilever a bit more complicated. So we can choose a peak that is alone, and there's no other peaks on the left side. Here we choose this 80 kilohertz, approximately 80 kilohertz, 77 to be specific. Now we are ready to approach. Click the approach button. The automatic approach will step the sample into the tip until the amplitude of the vibration suddenly drop because of the tip sample interaction. Now we are ready to approach the sample to the tip and perform contact mode imaging. In contact mode, as we have discussed in the early videos, first of all, you look at the deflection signal. Here is minus 0.5 volts. Go to the servo window and change the set point to be slightly over this deflection. In this case, we'll put 2.5 volts. So it is 2 volts higher than the free deflection of the cantilever. We apply the gain to a small number, 5% in this case. Go to motor, and then we can start this approach. Click the approach button, and the motor will drive the sample step into the tip. Now, the approach in progress window disappeared, and we know that tip and sample is engaged. We're ready to scan. First of all, go to servo, and then increase the gain a little bit to about 10%. Here, the scan, we use scan speed, about 2.5 line per second. Scan size, 2.5 micrometer, angle 0, offset 0. Back to the gain, as we can see that there is a little noise on oscilloscope. So we reduce the gain until this noise disappears. So we know we are at the highest gain that does not cause noise. And here we clicked the start scanning button and then start to scan the sample. Back to the files, we'll set up the file name, and this is gold 111 film on mica. Click save, and the image will not be saved until the scan finish. Using the exact same contact mode cantilever, we could also perform AC mode in liquid. No cantilever change is needed. Here's how. On the software, switch to AC mode. Put your set point at 10, so tip will pull back, and then perform a manual turn. Here we find a very nice peak between 20 to 24 kilohertz, and we put on the peak, which is around 21 kilohertz. Take a look, the amplitude here is 2.2 volts, and therefore we change our set point to a much smaller number. Tip and sample engage at about 1 volt. With all the other parameters exactly the same, we scan a little slow. As we can see here, exact same contact mode cantilever can be used to perform AC mode in liquid, with everything else the same. The difference between using contact mode and AC mode imaging a sample in liquid is that AC mode does not disturb some of the soft molecules or soft materials on the sample as much as contact mode does. So compare this image to the earlier contact mode image. There are several contamination spots on the sample in the contact mode appear to have a lot of lateral movements, while in AC mode, the contamination no longer have the lateral movements.